Welcome back, guys. This is lesson 5. It's called Proportions in Triangles, and hopefully it's pretty short and sweet here. Basically, I've organized your notes on the left-hand side. That's what we're learning, the theorems, properties we're talking about. On the right-hand side, those are the problems we should be able to do. That's us applying the new information. So there's kind of 3 things we're talking about today. Let's go ahead and jump into the first concept. It's a theorem, so we can prove it. It's called the side splitter theorem. Now, what this theorem says, it says that if you have a line that's parallel to one side of a triangle and this line intersects the other 2 sides of the triangle, and I'm going to stop right there and draw this line that they're talking about so you get a visual, but basically they're going to draw a line like in the middle of your triangle, maybe like that, and it's going to be parallel to one of the sides. So we'll call it parallel to this guy down here. And this new line that I drew, it intersects the other 2 sides of the triangle. So that's kind of the visual they're talking about. When this picture happens, this line right here, it divides these 2 sides that it's hitting proportionally. Okay, for the sake of like generalizing things here, this line, like we said, it's going to kind of like divide. Let me extend it. It's going to divide these 2 sides into like 4 different pieces, and they're going to probably give you those 4 pieces. For the sake of generalizing things, I'm going to call those pieces like A, B, C, and D. So there's tons of ways to set up this proportion. Here's what I do. This is what you'll see me do most of the time. I think of this parallel line in the middle here as like my fraction bar. So I'm just going to do this over this, A over B, equaling C over D. So this is just a really quick way to find a missing piece. It kind of avoids a lot of work that we've learned in the past. So it's a shortcut. And guys, let me explain to you, there's a lot of ways to set this up. Like you could do A over C equals B over D, C over D equals A over B. As long as you're not like zigzagging across this thing, you should be okay. But you'll see how I set it up, and I would just follow what I do. We've seen this problem number 1 before. In this problem, this is how we thought about it. Oh, these are overlapping triangles. There's like a small one up top. They're similar because of AA. There's corresponding angles, and they share that top angle. When they were overlapping before, we always redrew them. So we're like, oh, look, there's the little one. This side's 8, this side's 6. And then we drew the whole thing. And we're like, okay, I got to add those pieces together. So that's 18, and this is 6 plus X. Then we did like this over this equals this over this. You could still do that, but the side splitter theorem is going to cut that work down so much. I see that parallel piece in the middle. It's parallel to one side. It's intersecting the other 2 sides, and I've got those 4 parts. So I just think of that guy as my fraction line, and I can do 8 over 10 equals 6 over X. I'm going to get the same answer I would have gotten over here, but like that was so much easier and faster. So let's go ahead and do that from now on. Once I've got it set up, cross multiply, 10 times 6, and divide, and it's 7.5. Yes, the answer is a decimal. That's okay. Okay, on number 2, it says, well, why can't you use the side splitter theorem the way this problem looks? And I do see that piece drawn in the middle of my triangle, and it's splitting, like my 2 sides, it's intersecting into 4 parts. But that first piece is missing. It is not marked parallel. It has to be marked parallel for side splitter to work. If it's not marked parallel, these angles aren't congruent, these sides aren't even similar, or these triangles aren't even similar, that parallel piece has to be there. Okay, so that's why this does not work, not parallel. But let's force it here. Let's say that it was marked parallel. So let's actually solve this because this is a fun one. So let's say that this was parallel. I could set it up. I just use that as my fraction line. I'm going to go this over this equals this over this. So x over x plus 2 equals 2x minus 1 over x plus 4. And the reason that I want to do this one is because I want to practice here. So I would cross multiply and divide. I see a lot of addition and subtraction problems. I need parentheses. So here's what this is going to look like. And I warned you guys that if we were going to see like quadratics like this on the exam, hint, hint, we would practice it a few more times. So here we are, practicing it a few more times. A lot of distributing here. You've got a FOIL on the right-hand side. I just think of that as like extreme distributing. So watch what this is going to look like. X times x is x squared. Over here, I distribute the x, and I would get 2x squared minus 1x. Then I distribute the 2, and that would be 4x minus 2. Testing your algebra skills. Do you have any? Now I look at this and I think, all right, I got to put this stuff together. So I know I can combine those two, and I'm going to move the x squared over to get those guys together. So here's where I'm at. 4x equals, this would just be 2x squared minus 1x squared, which is just 1x squared. When I combine these, negative 1 plus 4, that's 3x minus 2. I still have that x squared in there. So this is a quadratic. And there's a plain x. So that means I could do like quadratic formula. This is going to be a factorable one. So I'm going to do factoring because for me that's fastest. So let me show you how I would do that. It needs to equal 0 for me to solve this quadratic. So I'm going to keep moving stuff over. And I'm going to move over that 4x. So that way it's like 0 equals x squared minus 1x minus 2. Now, when we factor, break it into two sets of parentheses. Here they both start with x and x. I am looking for two numbers that multiply to be negative 2, and they add to be negative 1. Well, what multiplies to be negative 2? Either negative 1 times 2 or 1 times negative 2. And I'm looking for which ones add to be negative 1. So if I come over my list here and add them, it's those two. So I'm going to slide those numbers in. Then I set both factors equal to 0, and I solve them. So here x would equal negative 1, yuck. And here add 2, x would equal 2. Wasn't that fun? Sorry, you definitely ran out of room there if I did too. Okay, obviously that made the side splitter theorem way more challenging because we did quadratics within it, but it's good practice for you guys. Keeps you young. All right, let's jump to the corollary of the side splitter. Remember, corollary just means like, oh, hey, this is a side note to what we just talked about here. So this crazy picture here, there's a super easy proportion to set up to find a missing piece in this guy. The corollary says if 3 or more parallel lines, so that's these guys here, intersect 2 transversals. So like there's one transversal, there's the other. Then the segments intercepted on the transversal, basically the pieces on my blue transversals here, they are proportional. So check it out. Don't overthink this one. I see 3 parallel lines. It could be more. If you've got parallel lines and then there's transversals in there, and hopefully you remember that word transversal, basically the different parts on your transversals, those guys are going to be proportional. And here's how I set this one up. I just take the pieces on my proportion, so like 4 and x, not on my proportion, on my transversal, and I make a fraction out of them. So I'm going to do like 4 over x, just follow that line, this over this. I went top over bottom, so when I look at this transversal, top over bottom here. I could go 4 over 6 equals x over 5, 5 over 6 equals x over 4. There are tons of ways to set this up. I would argue there's more ways to set it up right than wrong. As long as you're consistent and I just follow my transversals, you'll be good to go. Okay, solve this one. See what you get for x. It may or may not be a fraction. All right, on the back, last theorem. It's called the triangle angle bisector theorem. So this guy says, and again, we've got like a picture and I'll draw on the part they're talking about, but it basically says that if an angle bisector, so we'll have to talk about what that means. If an angle bisector divides the opposite side into two segments that are proportional to the other two sides of the triangle. So an angle, not if, an angle bisector divides the opposite side into two segments that are proportional to the other two sides of the triangle. I don't know about you, but yuck. That's just very wordy. It's kind of hard to follow. Let me draw a picture. So an angle bisector would be a piece that cuts an angle in half. So I'm just going to choose this angle down here. Let's say that I draw a piece in, like a segment, and that guy is cutting this angle in half. And I'm going to know that because they're going to mark both of those parts of the angle congruent. So here's my angle bisector. This angle bisector is going to divide the opposite side, and they mean the side that's opposite of this angle that's being cut in half. So across from it, this guy right here. So across from your angle that's getting cut in half, that side right there, that angle bisector is going to divide it into two segments that are proportional. So let's label these two segments, A, B. So those two segments are going to be proportional to the other two sides of the triangle, here and here. Maybe we'll call it like C and D. Okay, again, super wordy. Here's how I set this up though. So like there's my angle bisector. It's going to break that opposite side into two pieces, and those two pieces are proportional to the other two sides of the triangle. As long as you keep this consistent, you're going to set this proportion up right. So here's what I do. Again, I kind of maybe think of like this guy as my fraction line, and I'm just going to take the two sides of the triangle and I'm going to go top over bottom. So C over D equals A over B, top over bottom. I cannot stress this to you enough. There's a lot of ways to set this up. C over A, D over B, B over D, A over C. As long as you're not like crisscrossing, you're probably going to be okay. I'm going to do the first one. You're going to do the second one. Okay, I know this theorem applies because I see an angle bisector here. This guy is cutting that angle in half, and I'm given the two pieces on the opposite side, and I'm given the other two sides of the triangle. So I just use my angle bisector line as like my fraction line. So I'm going to start on top and go like 5 over 8, and then come back to the left, 3 over x. Once I've got it set up, should be super easy, cross multiply and divide. So I'm going to do 3 times, whoa, we'll help before on here, 8 times 3 divided by 5. Don't you love decimals? The answer is 4.8. See if you guys can get the correct answer for x, and that is going to wrap up lesson 5.